Working with right triangles in the past, we've been utilizing Pythagorean theorem. And what that has allowed us to do is if we know the length of two of the sides of a right triangle, we're able to find the third side. And using the formula a squared plus b squared equals c squared, and then that would tell us that when I had that right triangle, a and b would represent the legs, and then c would represent the hypotenuse, or the longest side across from the right angle. So as long as I had two of those, I could find the third. And then we learned what we're talking about here is that in a right triangle, the sum of the squares of the lengths of the legs is equal to the sum of the length of the hypotenuse. And all they're doing is saying, hey, a squared plus b squared is equal to c squared. Now, in using that, we notice that when our numbers work out to perfect values or integers, for example, if a was equal to 3, b was equal to 4, what would c equal? Well, that would be 3 squared plus 4 squared is equal to c squared. 9 plus 16 is equal to c squared, or c squared is equal to 25. And then when you find the square root of both sides, we find out that c is equal to 5. Since that came to an integer, what we find is that we have these perfect Pythagorean triples where they come to these whole numbers. And so what we have here is this is a 3, 4, 5 Pythagorean triple. And we find out that there are other combinations that make up a Pythagorean triple, being some of the more popular, 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. So as a Pythagorean triple, if you have anything multiple of each number of the triple, then you have the same thing. So for example, 3, 4, 5, well, 6, 8, 10 would be taking this and multiplying each number by 2. 9, 12, 15 would be multiplying each number by 3. And so they're saying, hey, technically, if they are increased by the same factor, then we still have that same Pythagorean triple. And that's what they're showing here. So we'll do a little bit of practice, but just being able to recognize here, using the Pythagorean theorem to find the missing measures. So again, the side across from the right angle is going to always be my hypotenuse. So here we have a, b, so when they filled in the formula. And then they went ahead and substituted in 17 squared plus 7 squared is equal to x squared. So 289 plus 49 is equal to x squared. Combine like terms, x squared is equal to 338. Square root of both sides is going to give me the square root of 338, which they simplified the radical to 13 square root of 2. And I will just say that is approximately 18.4. So again, if you have difficulty simplifying radicals, just make sure that you can convert back and forth between decimal and simplified radical. These values right there. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. So looking at my Pythagorean triple, what they're hoping that we can recognize, what are my Pythagorean triples again? So as we were working with this, they're trying to say, hey, can we recognize, are these any of my triples? And I would just say that, what do we know? That this is always going to be the longest value or the greatest value across from the right angle, which is 50. And then I could say, are any of these factors of 50? And I could say, hey, 25 could be, or 50 could be 25 times 2. And then 14 could be 2 times 7. So that's what they're trying to say. Hey, can you use a triple to find this out? And this would be 7 times 2. This would be 25 times 2. So this is probably going to be equal to 24 times 2, or in this case, 48. Okay, so now if we didn't know how to do that, we couldn't recognize that, what we could do is we could have said, okay, this would be A, this would be B, this would be C for the Pythagorean theorem. And I know that A squared plus B squared is equal to C squared, and you get 14 squared plus X squared is equal to 50 squared, so subtracting 14 squared from both sides, X squared is going to be equal to 2,304, and then finding the square root of both sides. The square root of 2,304, X is probably going to be equal to 24. Now, nope, X is going to be equal to 48. So again, if you don't recognize a triple, you can still use the Pythagorean theorem, and if it comes out to that integer whole number, then we know that it is a triple. So here I could do the same thing. Maybe we recognize that this is, gosh, 20 and 48. That could be 2 times 10. That could be 2 times 24. And I don't know that either one of those are a triple. But this is also the same thing as, let me see here, 4 times 5 or 4 times 12. And that would be this one, because this would then be 4 times 13. So the X value would be 42. And again, if you don't recognize triples, then you still have the Pythagorean theorem. So the value is X is 52. Apparently I had a little bit of a mathematics problem there. 4 times 13 is 52. So, but yeah, you could have done the Pythagorean theorem and had the same effect. Now, using this in application, I would just say that it wouldn't be algebra or big math without a little bit of word problems. And it says this summer camp is building a new zip lining course. The designer of the course wants the last zip line to start at the platform 450 meters above the ground. So we are up here 450 meters above the ground, and it ends 775 meters away from the base of the platform. Base of the platform, 775 meters. How long must the zip line be to meet the designer's specifications? So they're just saying, hey, what is this going to be? And since it's across from my right angle, that would be the C value. So you have A, B, C. Doing the Pythagorean theorem, they filled in all the blanks down here. A squared plus B squared equals C squared. 803,125 is equal to X squared, finding the square root of both sides. And when they did that, the square root of 803,125 is approximately 896.17. And that's how much wire they need in order to successfully create a zip line. Anything less than that, no zip line. And then here, looking at this one, we have the same little word problem going on. Ramps. So Lincoln High School is installing more wheelchair ramps around the school. ADA compliant, always an important thing. One of the new ramps needs to have a base that is 12 feet long. All right, so if I'm building a base, I need to have it 12 feet long, they said, and it reaches a height of 1 foot. 1 foot. If the side of the ramp forms a right angle, how long should the inclined surface be of the ramp? Here is my inclined surface. So again, A, B, C. So you would have A squared plus B squared is equal to C squared, or in this case, 144 plus 1 is equal to C squared. C squared is equal to 145. Find the square root of both. C is equal to the square root of 145, which is approximately equal to a very 12 point something. And this is one of those problems where you have to be careful because the decimal comes to 12.0415 and keeps going a little bit. But when you round this, you have to be careful. You know, find the exact length of the inclined surface of the ramp. You can't just round to 12, okay? So I would either say 12.04. That's it. I would say 12.04. You could add more decimals in there, but do not say 12. You wouldn't have a ramp if it was 12. It is a very small portion above 12, but it has to be above 12 because the base is 12. You know, if it wasn't greater than 12, then you wouldn't have a ramp. So the converse. Now, the converse of the Pythagorean theorem is saying that if the sum of the squares of the lengths of the shortest sides of a triangle are equal to the square of the length of the longest side, then you have a right triangle. So they're just sort of going in reverse. Before it was, if you have a right triangle, then you can do this. Now we're saying that if you have this, so if, they're just saying the reverse. So if the sum of the squares of both sides equal the square of the hypotenuse, then you have a right triangle. So we're just moving back and forth through the definition or the theorem. So what that means now, we know that, again, Pythagorean theorem, if a squared plus b squared is equal to c squared, then we have a right triangle. Okay, but they're saying if for some reason c squared is less than a squared plus b squared, then we have an acute triangle. So think of it this way: the legs a and b are greater than or overpowering the hypotenuse, so we decrease, we get smaller than 90, and then when the hypotenuse is greater than the two legs, then what we have here is that we have an obtuse triangle. So we have gotten larger than the 90 degrees. When the legs, shrink the hypotenuse, basically it sort of looks like, we got pinched between the legs, that the hypotenuse we have decreased and we have created a smaller triangle or acute. So when c squared is less than, it is acute. When c squared is greater than, it is obtuse. And when c squared is equal to, it is right. So there's going to be a limitation because you get a point where maybe we spread so far apart we don't have a triangle, but we'll look at that. So here, just understanding that determining whether the points of this triangle can be the vertices of a triangle. If so, classify the triangle as acute, right, or obtuse. So let's see. So they found the distance. They found the distance between A and B. If I just created a triangle here, it doesn't have to be drawn to scale. A, B, C, this is 2, 2. This is 5, 7, and this is just for visual effect. And this is 10, 6. So there's my triangle. So they said, hey, how long is AB? How long is BC? How long is AC? So they said that AB, AB is actually going to be 5.83 once they do the distance formula. BC is going to be 5.1 after the distance formula, and then AC is going to be 8.94, using the distance formula. And then now they have to determine the two smaller sides and the larger side. So we take the largest side should be the one that would be C. So the largest side should be C because that would be the hypotenuse across on the right angle. And then they just make that determination of using this triangle inequality theorem. It says, use the triangle inequality theorem to determine whether the measures of these two can be a triangle. So let me see here. These two sides are greater than this side, okay? These two sides are greater than this side, or these two sides are greater than this side. So the side lengths, which one of these is going to be a true statement? And of course, they're all true statements, so they are all eligible to form a triangle, but then we have to think if we utilize the, hey, this is C, we could then go ahead and just do the determination of C squared, is it equal to A squared plus B squared? And when they multiplied that out, they found out that C squared is 79.9, and that is greater than 60. So that would be, if that would be that, see, they're not equal, so it's not a right triangle. So if the hypotenuse turned out to be larger than the other two, that would be something along the lines of obtuse. So looking at this next question, it's saying determine whether these points, J, K, L, can be vertices of a triangle, and if so, classify the triangle as acute, right, or obtuse. So what I have here is I've just drawn something for reference. I've labeled my points, and now I'm going to go ahead and calculate the distance from all of these and then see what I have. So I'd encourage you to go ahead and stop the video and then see where we're at. Check your answers. So looking at the length of JL, I went ahead and used these points, x2, y2, x1, y1, did the distance formula, and I have come up now that JL appears to be 5. So as I go on to my next equation, I'll make sure that I'm going to find JK now. And then when I found the length of JK, using x2, y2, x1, y1, I believe JK is approximately 4.5. And then now I'm going to go ahead and change this one out, and I'm going to go ahead and use that as x2, y2. So I can turn around and do KL or LK. All right, so doing that, I think it's going to be approximately 2.3. This is approximately 4.5. So this should be my C value because it is the greatest side. I do know that it's not, 3, 4, 5 was a perfect triple, so I don't think it's going to be a right triangle. But if I take and just call this A, call this B, call this C, that would be 5 squared, and I don't know, but 5 squared, so that would be C A squared plus B squared, so I would have 4.5 squared plus 2.3 squared is going to be 25, and that's going to come to 25.54. So according to this, A squared plus B squared is greater than C squared. Looks something like that. So I am pretty sure that would mean that that is an acute triangle. So yeah, it is going to be an acute triangle because the two sides A and B squared are greater than the hypotenuse. And that is just being able to use some of those definitions and making those determinations. So there you go. Hopefully this aids and helps, and then we will just go ahead and continue with doing these and working on some more with the Pythagorean theorem.